Okay. Just hold it on there until get someone in the room. Like
there's a lot of people watching on YouTube.
Is that?
Yeah.
Why do I see?
There we go. Streaming. I see it. I see him.
You see him, but we doesn't report any views. Oh no, 12 views.
Yeah.
Okay, you need to send the audio.
There. It's thing.
So, is this the guy in the modern era that lit the new fire? And is the new fire going to be lit in this room over the next few days? That is the question. A bit of the old fire out there.
Of sorts.
Okay, so we're going to take a first look at the reactor, which is after we've showed our lab experiments. Yes. We now have white shirts for the experiments. Okay, let's go and see what we can see with the reactor. I think you can see it in the background there. Over there. This is the Aura device. And we have, I think, is this the steam output? Steam output comes from here.
I believe that's on the front is the steam.
Yeah, and around the back there is the water input. And then over here is the cockroach container, where all the energy is generated. Apparently. No, I'm joking. We don't know what that is. And then down the end here is quite elegant. You have the power and sensing through this end. And over there, there's the cables on top of the control device. And apparently, when it's plugged in, we'll have the on-off control here. And here is the pump. That will supply the water to be made into steam, hopefully, which will come out of this bucket over here. No, is that our sparging bucket? That's the sparging bucket. And this is the source water for the reactor. And the sparging bucket is on the Arlen scale, so we can accurately measure that. And it's made from a copper pipe, which goes into a coil, and then at the end of the coil, there are holes for any residual steam to come out through. Okay, so I'm going to hand over to Ryan, who's going to point at things. I can hold myself.
All right. We have a lot of instrumentation brought to bear on this experiment. We'll start with closest to the reactor. We have an antenna, and that is hooked up to an RF spectrum analyzer that goes from 0 to 2.4 gigahertz. And that should cover the range, and we'll just kind of see if there's any interesting spikes that happen when we turn it on compared to the background. We just got that background into the data file. Underneath here we have this is a photographic film plate. And we have various metal pieces on there. I'm going to talk through this. So this is two 10 by 8 plates, 400 ASA high sensitivity. There's one below sort of polymer fiber thing to stop the light coming in, and then there's a sheet of aluminium, and there's another one on the backside. So the backside negative has a very large amount of sort of aluminium in front of it. Now we have here. This is 3 millimeters of aluminium. This is 1.5 millimeters of aluminium. This is a file which has holes in it, slightly suspended at either end, close to the top of the film here. So maybe we can get some co-limited photons through here. This is me written in lead.
and this is 356 in steel. This is about 3 millimeters of lead. This is about 1 millimeter of steel. And at the back there, we have 2 millimeters of lead. And we have 4 millimeters. So 2 millimeters of steel and 4 millimeters of steel at the end there. And obviously, all of that on the back plate has the option to have another sheet of aluminium in front.
Okay, so back to Ryan. We don't have a speaker in here, but we're getting a serious echo, they're saying.
It might be more than one microphone. Okay. Let's see if we can. You might be up from the phone as well as the. Let's see. Right, we're going to try the audio. Try and do that in a slightly different way. So people can say if they are hearing more than one audio. Here and audio. So maybe if I kill this one. Can you still hear me? No, is there any, there's still audio there, so that must be coming from the phone. Is there less echo now? Can people say if there's less echo? Because we're not watching our own stream. Echo? Is there an echo? Is there an echo? No,
Perfect. Good now.
Excellent. Right. There's no echo, by the way. We're testing the Aura device, so don't get confused.
Right.
Okay, so just to recap, we've got a whole bunch of metals of different thicknesses. We'll take a photo and specify what they are. But this is lead, steel, aluminium, various thicknesses with the 10x8 plates. And back to Ryan. Do you want to run over the few bits that you did before?
Yeah. Let's start. Start on this side. This is the main data collection laptop. It collects data from the lab jack. The lab jack is wired to collect from the radiation counters, and it has the temperature input from the Optrus, and it has the flow meter and temperature sensors, and we'll go through them one by one, and the power analyzers. At least the power analyzers come in USB. So we got the PC830. That's an inductive clip. It can do 3-phase. It's only being used for 1 phase in this job.
Can I ask if the clip's on the right way round?
Brian?
I just barely switched it.
Yeah. So the current's pointing this way, the arrow. So
we were measuring negative power.
Yeah.
And that's why I switched it.
Okay. So yeah, coming this point, you got the plus there. So
that's the backup check for the main power meter, and this is Tektronix PA1000. It does how many? What resolution?
1 megasample per second, and it can display the first 50 harmonics. That's up to about 6 or 8 kilohertz, based on a 50 hertz mains frequency.
And most importantly, it measures the current with a shunt inside of it, so that it does not. It's going to be able to tell us if there's a DC offset, which the inductively coupled current clamp can. We have a small scale. This one is a backup in case our other one fails for any reason. So far, we haven't had to use it. We have this cute little device. It's called an electrosmog meter. And it's a simple device for measuring the amount of, oh man, it's picking up.
That's my phone.
Strong signal off the phone that we're using.
If I bring the phone closer, it gets a lot.
Yeah, imagine putting that in your pocket.
Yeah. So anyone that wants children that look, healthy, I would suggest keeping your phone away from your pocket.
Now, before we had the camera right here, I was going around, and you can see right over here by the reactor at the moment, it's really low. Well, it's low until you get close enough to see it, I guess.
Yeah. But the good thing is it gives you a specific frequency that's the peak, isn't it? So if I get close, it gives us, so what's that reading on the megahertz there? Or
need more light on it.
2.4. Could that be Wi-Fi?
Yes, that's probably Wi-Fi. So we'll be sniffing around it with that without the camera on, extremely close. That does not log. That is just, that's going to be video logging only.
Mhm.
We have a scope in case there's anything we want to look at. Then we start getting into the radiation monitors. We got the GMC 30 with a, what kind of tube?
320, yeah. The 320 plus with the LN7317 pancake tube that Alan fashioned this box to house.
Excellent. Underneath here, I have another simple little Geiger counter. And we'll see what the best way to arrange that is. The sensor tube is right here, so we're probably going to want to elevate that and have it as close as possible. And then we have our Ortec sodium iodide crystal, the one we thought wasn't giving us very good readings, till we got it in here, and then it was actually, it's been performing very well.
Oh, digs were lots of wood, wasn't it? So
yeah, it was a little different in the accommodations that we have. The flow meter, oh, we have the neutron, the low energy neutron reading.
we got one here and we got one a little bit further away here.
The idea between that is we have some that are close, but if there's a like a universal thing going on, a wide area effect from change in weather or anything like that, we'll have one that's basically continuing to log closer to background. We'll be able to see that trend change.
We have some other neutron detectors, don't we?
Yeah.
So on the back plane there is two types of bubble detectors, bubble detector thermal and personal neutron detector here with the relative sensitivities, which we will publish, of course. Nothing in there at the moment. Oh, there is one bubble in there. What's that? There's one bubble in this one already. Look at that. Very, very clear.
That's normal.
That's normal.
In the BDP and D.
Yeah. Yes, that's it.
Yeah.
Okay.
Then we have the flow calorimetry system. We have a filter. The filter protects the fine little flow meter that we have here. And unfortunately, we had to turn the gauge, the visible display, away from the camera.
Why was that?
We had to turn that in order to get a nice straight line between here and there to make sure it's as accurate as possible.
Mm-hmm.
We have normally a cold temperature sensor goes in here. That it looks like this. We've pulled it out to be able to put it in the bucket that will be sparging, and that just screws up inside a thermal well that's visible in here.
So yeah, this is the thermal well and the sensors going into that. And we've got a clear pipe there. Why is that?
That is to detect bubbles.
Or air. Bubble. We don't want any things in the line. We just want water, right?
That's right.
Because the flow meter, if after the flow meter we saw like air or bubbles in here, then there would be questions about the flow meter's reading. But there we go.
Right. So the water comes up. We have these nice telegenic meters here, so that'll be easy for people to tell, even on not so good video, that what the temperature is. Yeah. So we've got Bob's adjusting this camera a little bit.
Mm-hmm.
All right, so the water comes in through the flow meter. We measure its input temperature, and then it runs through the heat exchanger and out to the output temperature. And we have the same thing, the same kind of sensor in the bottom, and we have the same dial up here, and then it comes out. And we have a drain line that'll take the water out the back.
Out the back through the famous back wall that you may have seen in any other Me 356's experiments.
Yeah,
There's
yeah, you can see
out there.
You can see the daylight through there.
Yeah.
At certain times, we will pull this out with a cup here. And the cup is just so we can transport it without spilling over everything. And we will start filling a bucket on the scale.
Mm-hmm.
And that way we have the Arlen scale which is a precision instrument capable of 100 pounds.
44 kilograms.
44 kilograms, and that can read down to roughly half a gram.
Yeah.
Which is an amazing feat. There's a few little idiosyncrasies to how it does that we spent quite a bit of time researching, bumping into. But that's logged also through the USB into the main data collection computer. And so that's part of the streaming. And that also calculates then for the temperature difference, and the mass flow rate, the amount of energy output that the device is giving us. Let's zoom in a little bit to the census meter. In the heat exchanger here, the device will put steam in the top. It'll condense in here by the cold water running through it. And then the condensate will come down here, and it goes out a hose and out the door back there.
All the way, there's the hose that runs around the room and out the door.
Yeah. The water connection is actually underneath the table. It's a little bit awkward.
Yeah.
And it's got a drip.
It's got a drip.
100-year-old pipe.
Yeah. So it goes into this container down here, the drip through this funnel. It's not a very big drip, but
that's just so we're not walking around sloshing.
Yeah.
I'm trying to avoid that. So the census meter is actually a triple check on the amount of flow and the temperature difference that we're collecting here. So the amount of the heat that's coming out of here, out of the Aura device, will be captured by cooling water, and then it'll be that water will be discarded. No, yeah, the steam condensate will be discarded. And so, yeah, we got triple checks. Everything we've got 2 or 3 ways to measure it. We should have, when they disagree, it'll be really interesting.
And if the steam, the condensate is below a certain temperature, we might close loop it back into the Aura reactor. But initially, we don't want to do that until we understand what the condensate temperature is.
Right, the condensate, we have to be able to get that down under probably 50 degrees in order for his feed.
And also, if it's truly dry steam that's being outputted from the reactor, then the bit of heat that's latent in the sort of heat that's left in the water is not going to be that significant, right? So,
right.
Okay, so carry on.
Let's.
So we got the big clock down here, which we'll use.
Let's take a look at the Optrus camera.
Oh, yeah.
The Optrus camera is, we can stream that video, we're recording it. We have another webcam on top of that.
That'll be the main webcam for many of the experiments.
And what other instruments and stuff?
Well, we got a new light, so there's plenty of light in here.
Oh, point out the camera up here.
Oh, and we've got a spherical camera up here. You might have seen us using to set up the other day and take down. So this is actually recording this whole thing, which will upload this video. So you can look at it from a different perspective. You can choose your perspective.
And we have an ultrasonic microphone.
Yes, we do. Yeah.
Which is wired in through Audacity to measure the ultrasonic sound spectrum in case.
What's the specification on that?
We're sampling at 384 kilohertz, which gives us 192 kilohertz of maximum resolution. This is the background noise. It looks pretty loud. This is normal background noise. This is called 1/f noise. There's a peak here that is probably the DC to DC converter in the microphone. It's down 42 decibels, which is about 1/100th of full scale. I don't know what this peak is. I just did this recording a while back, and it looks like it's about 50 kilohertz. And so,
but we did a test with a Samsung charger, switching, like high frequency switching charger.
And we could see the sound from that.
And there were very, very clear, distinct peaks, weren't they? A number of them. Yeah. So maybe we'll see something with that. Maybe we won't.
By having the background sound, as you pointed out, we can subtract this background spectrum from any anomalous sounds that we
Just
find.
like we do with the, the spectrum analyzer
Yeah.
for the.
Noise suppression.
I can show that video, or show that being updated here too, if you want.
Yeah, sure. So what are we looking at here now?
So this is our spectrum analyzer software,
Mm-hmm.
and I'm running 0 to 1 gigahertz, and by 500 kilohertz steps.
Mm-hmm.
And we'll just compare. I don't know what all these little things are, what sources that, there's a lot of sources of RF in here at the moment.
Yeah.
And we'll be able to compare this to during startup. We'll try to record. It's got a video record function. So we'll do that during the startup and into the first run.
And Brian, you have attached another sensor to the overall array this morning, didn't you?
Just the Optrus is now attached. The region of interest.
Yeah, so the Optrus is on the streaming computer, and you can see here. And at the moment, we've got the region of interest set to the hottest thing in the room, which is currently, what is that? What is the hottest thing there?
Is that the flow meter, or is it?
Oh, it's over on your desk because it's pointing at the desk currently. So
Is it
something on the desk.
Oh,
It's probably the phone.
Yeah.
Oh no.
Anyway, so this is not so useful, so there's no point streaming that at the moment. And we have a camera that's watching us, so Me356 can have some idea of, well, whether something's blowing up. He has the ability to set parameters and monitor in his office. But really, we will have charge of the reactor controller, which is here, and we can start and stop that. Apparently, it takes about 10 minutes to get up to full speed, or whatever that means. So we will need to start and stop it to do the sparge testing, and then to put it in for the flow calorimetry. So just to be very clear here, we're going to be able to measure through this flow meter, and then separately through this thermal watt meter, which has a flow meter built in, and that'll be on the same system. These can agree or not agree, but they tend to be really agreeing in our tests so far, in our base digs, didn't they?
yes, they performed within 5%.
And how did that compare to using buckets?
No, on B, I guess the buckets were within 5%. The other flow meter was really tight.
Right, yeah, because you had something like 1 liter a minute on here, didn't you? And this was reporting 0.06 cubic meters per hour, which is
exactly the right ratio. And when the two temperature sensors on that one, I calibrated them in a pan of ambient temperature water, room temperature water. They were within 0.018 Celsius.
okay. So we're going to sign off here in a minute and get everything hooked up.
Actually, we're going to weigh them and measure them.
Oh yes, let's weigh them. Right? Yes, these are metrics.
We've been waiting.
Yeah.
All right, who wants to? I'm going to log actually.
Okay.
Ryan, and why don't you guys?
Do measurements.
Why don't you measure? I'm going to write it down.
Okay.
So about the Faraday cage discussion and other things, we are on a wood table which has wooden legs. You can see under here, I'm under the table and there's nothing under here. And it's up on this kind of like a shutter ply and these blocks. And so, you can literally lift this thing up with one hand, and it's not attached to anything. And that's basically it. So we're going to do some measurements, and we're going to weigh it.
Let's move the bucket and use the R line.
Yeah.
Okay, let's do length measurements first. (52.5 centimeters).
Yeah, I agree.
Okay.
We've not done this before. You're watching us do it for the first time. So.
8 centimeter.
Yeah.
So 8 centimeters square.
Extrusion.
Yep.
So the box at the back.
Hamster cage,
Cockroach container.
4 centimeters by a little over 7.
And
4 by 7.
It's square, 4 by 4 by 7.
No, it is 5 tall.
can we measure that one? It's need to be a bit tighter on the measurement of that.
Can you make a sketch?
That's 7.
7.
Yeah. Very precise.
Yeah. So 7,
It
long.
extends out 7 from the main box.
And its width is 4.
And how far is it down from the top edge? It's just the thickness of the.
Yeah, not much.
We can't rotate it, so.
3 millimeter.
3 millimeters down from the top. That should give us everything else. Do you want to measure the distance from the end to the steam vent?
Sure.
Right now.
23.
Which end?
To the center point of the steam vent.
From the.
From the end,
With the cockroach cage.
Okay. How many?
23.
And then for the back side, for the water in
Measure it
jet
from this end.
from the non-cockroach end.
11 and a half.
Yeah.
We'll call it.
Great.
Water inlet 11.5 from the end.
And then do you want to, is there anything relevant around that side?
Well, we can measure the
Yeah,
position
the
of
opposite
the
end.
connectors.
Yeah. I'll try and get the camera around there.
What do you want to measure to?
Yeah, from the edge, and then the diameter of the connector, it's a standard connector.
It's the light's pouring here, but 10 millimeters from the non-cockroach,
The non-cockroach side.
the steam exit side.
Yeah.
Probably. If they're round, you measure the center.
We can do a center measurement if you like. It's 24,
From the top,
yeah, closer to 25.
and then how square is it? That'll give you. How much square is it? The actual main power connector is how much?
26 width by,
I'm gonna need a photo and
30 high.
Okay.
draw lines here.
And the diameter and of the that one. So that's the
18
yeah.
diameter.
That's for the control, not the power.
Right.
Control and sensing.
Do we need to give you a sketch with the dimensions?
Yeah, I'm gonna need a photo we can mark up.
Okay. And then from that top, the other side. Yeah, top down and from the other side.
Top down is 30.
So that's the control and sensing. It's really painful.
15.
Okay, from the cockroach side. Okay. So then, weight. Now there's a lot of water on the Ireland scale.
Okay, Alan's gonna take some pictures.
I need something to dry off the Ireland scale. A shirt would do it. Anyone got one? Out there. If you don't know where your shirt is, I've got one in the car. Oh no, I've got some socks here.
Oh,
Cunningly, I have them in my pocket. You can use my socks.
Okay, that works.
They're clean, but I can sacrifice them for this. Why have I got socks in my pocket?
You that they're clean?
Yes, they're clean. I only wore them once. So you might get the impression that the space is quite tight, but it's surprisingly roomy when you get used to it.
It's really quite tight. But we think of it as cozy.
Yeah,
At least it would be if it wasn't.
it's lucky we're not playing with electricity or water.
Yeah.
And the water's cold. Honest.
All right, here's your wet socks.
Oh, thank you. I might expect to put those back in my pocket.
Yeah, put them on.
Wet socks.
All right. Okay, should we measure the control box first?
Yes.
Do you want to measure the cables separately or included?
Anything that, if they're attached to it, that's what.
We can fit it all on here. Okay, it's on pound. Hold on 1 second. Okay, the control box and cables are 1612.5 gram.
1.6 kilograms.
Can we lose the cables and just measure the control box?
Sure.
Do you want to hold the cables? It's screwed in, isn't it?
Yeah.
Comes out like that. So, this.
Okay, you got the cables?
Not that one. Yes, I have
Okay.
now. Yeah.
Control box alone is, we'll call it 831.5 grams.
So it's about half the weight.
Yeah.
Now it gets a little trickier because when we weigh, hold this. When we weigh the reactor, it's dry. There's no water in it yet.
Mm-hmm.
So we won't know until we run some water through it what its wet weight is.
But we will know the volume of water that can be held in the reactor.
Aha, yeah.
If we unplug everything and stop the water draining out.
Yeah.
Okay. Just for a little tidbit, I don't know. This is all we can get to see. There's just like, I don't know, some sort of foil or something going around there. Anyway, so shall we put it on the scale? You're going to tear the scale up?
Okay, let's.
Did you tear the scale before, by the way?
Did you?
I don't remember you saying so.
Let's do everything.
Let's do that again.
That was
Because,
a lot of fun. Let's do that again.
yeah,
No problem.
I see something that looks about the weight of water.
Yeah. Where was that on our checklist?
Yeah.
Yeah.
Okay, I'm gonna unplug this for now.
I
Is
don't
that
see
okay?
why it needs to be on, does it?
Okay.
It's not doing any pumping. Okay,
All right.
so he is tearing the scale, and it is reading 0. So
Okay. Now let's measure the control box. 872.
do you want to drop the cables on top?
Yes. Where did they go? Right here. Thank you. With cables, 1652 grams.
All right.
Okay. Ready for reactor?
The moment of truth, yes, why not?
What was it with cables again?
Oh, it needs to be teared again. It's just drifted off.
1652 for cables.
Okay, it's teared.
Oh, 780 for the cable.
Okay, ready for weight of reactor?
Yes.
3017 grams. 3017.
All right.
Okay.
Next step, we're going to have to turn off streaming so we can have,
The man come in and hook everything up.
yeah, and then we will resume streaming.
Or actually, it might be someone that lives in the dungeon here. We don't know. There's a speculation as to whether Me356 actually built this reactor, or he's got someone tethered to some chains in the dungeon here. Anyway, so thank you for watching. Signing out. We'll come back on as soon as we can. Thank you for your attention. So I will stop the broadcast. Goodbye now.